solved by graphing. We have solved by finding the square root, and we solved by factoring. So when we solved by finding the square root, most of the time we noticed that there was only that ax squared term, because if I only see x once, I can get it by itself, isolate and solve. Then we started to add in that trinomial, or even a binomial. When we had that ax squared and a bx, at that point I can't square root to solve. So if it was in the form of a trinomial, we could factor it. If it was in this form yesterday, or even as we were factoring, you could find the greatest common factor. Today we're going to look at examples where you're dealing with trinomials that do not factor. Okay. So as you're going through these problems, if you see that you have a trinomial or even a binomial, anything that you have, and you're trying to factor, which would most likely be the first thing you try, if you find it, you just can't find factors, and you just don't think it factors, even if there are factors but you cannot find them, this will work. So visually, I'll show you what this is first. If you look at the visual, it actually makes, as you go through the visual, hopefully it makes a little bit more sense. These algebra tiles here represent x squared plus 8x. Okay, like I said at the beginning, this is going to be a little different, so bear with me. We can rearrange that same figure, those tiles, to actually make a square. The problem is the square's not complete. Right, so if I took that x squared and then these 8 green tiles and I rearranged them to actually make a square shape, I would need to do something to complete it. Right, what would I have to put in there? How many little blocks would fit? How many little constants would fit?
16.
16. Okay. So this is what we call completing the square. Okay. So in order to complete this square, we would have added in 16 blocks. You don't have to write anything yet. I'll show you which slide. Why would we want to do this? And this is the question that hopefully comes up as you go through. The reason we would want to do this is because if I create a trinomial that is a perfect square trinomial, I can easily factor it. And this is where we want to get to. So here's what we can do. Okay? Right, this is what I would write. You can change an expression, x squared plus bx. You can change that into a perfect square trinomial by doing something called completing the square. And the way we do that, we will use this formula, b divided by 2 squared. This is called completing the square. I'll show you visually what we're doing when we get to an example. Completing the square. This works if b is positive or negative. And we can complete the square in a few scenarios. You can complete the square when your trinomial is not factorable, or if you just can't find the factors.
You can do this if it's wrong.
A few of the practice problems that we're going to do, I'm going to put a few up on the Google Classroom, and actually one that I'll give you later. It's nice to actually practice this process with trinomials that you could factor and find the answers to. You'd get the same answers. So it's really great to kind of know the answers already and then try this method. We're going to do an example like that towards the end. going to determine the value that you add to complete the square. And again, think of the visual. We're going to take it from like that long rectangle and we're going to make our expression into a square. We're going to fill in those missing pieces. I'll show you why it's b divided by 2 and squared in a moment. Let me see it visually. Is anyone still ready? So if I had this expression, x squared minus 16x plus c, if I wanted to use b divided by 2 squared, what would the value be for this?
Can we write this down as an example?
Yes, absolutely. What would I plug into that formula?
16.
What kind of 16? Yeah, I would plug in a negative 16 divided by 2 and then squared. So let's just take a look at what this would look like visually. X squared would look like that. If I wanted to make this a square, I have my x squared here. How would I have to divvy up the 16x? There would be 8 up here. 1, 2, 3, 4, 5, 6, 7, 8. And then 8 over here. 4, 5, 6, 7, 8. Which is why in the formula you're taking the negative 16 and dividing it by 2. And then how would I actually figure out what's in there? What would I square? Yeah, I would take, think about rows of 8 and columns of 8. There would be 64 in here. That's why we square. So the value that we would add to finish or complete the square would be 64. Because here, what did we do? Negative 16, we put it into the formula, that little b divided by 2 squared. If you don't remember the formula, if you just visualize breaking this up, you could actually see, all right, well, it's 16 x's. I'll make it a perfect square. So like 8 have to be here, 8 have to be there, and then you could figure out what would go in there. So b of negative 16 divided by 2 is negative 8. Squared, negative 8 times negative 8 is positive 64. Okay. So first we're just starting with using the formula. Heads off the desk. This is what you're going to use to find the value to add to complete your square. You're going to try one, just like this. What value would you add in to complete this square? To make that a perfect square trinomial, what would this value be? Using this value we have, think about what you would calculate, what you would put in. Try this. David, what'd you get?
100.
How'd you get 100?
Because 20 divided by 2 equals 10, and 10 squared equals 100.
Good. And again, if you needed to see this visually, you had the x squared. If you needed to break up 20, you would put 10. And then 10. And then what would actually have completed this square? It's a 10 by 10 grid. There would have been 100 constants. So you would have added in 100.
I have a question.
Yeah.
How come we don't take the x with the 20? Like, doesn't the x be a part of the whole thing, like with the 20? Why don't we take it?
What do you mean take it with it? It's still there.
Where?
These are x. These represent the x, and then the big box represents the x squared. Like remember algebra class? Algebra class.
Oh.
And then the constants are the little boxes.
I don't know. I mean, I get it.
So now we can use this to solve. Okay, and here's why. What did we just do? We took a trinomial and we created a perfect square trinomial. Okay? Is that x squared minus 14x plus 16, is that a perfect square trinomial? No, it's not. And the problem here, that's not factorable. I can't factor it. Okay, so if I'm looking at it and I'm going through and I said the problem said solve this quadratic, and I noticed it was a trinomial, but I'm trying to factor and find factors of 16 that add up to negative 14. I can't find it. I can complete the square. So I can rearrange to actually complete the square. But here's the problem. When I complete the square, what value am I putting in? Like what part of the trinomial? The c value. What's the problem with this? I already have a C value. What do you think I could do with it if I like didn't want it? Yeah, I could actually get rid of it. So here, I really want to complete the square and find a new C value, but I need to get rid of this first. So I can subtract it. Because now that I do that, I can work my magic. And I can complete my square. On the next slide, you're going to see the entire problem done from start to finish. Do not panic. It's a lot. Okay? We're going to go through it really slow so that you see what happened. Okay? Promise you, this is very out there, but over time, I promise you, it'll make sense. I can also explain why we would do this. Okay. Don't worry.
Oh.
Who made it? I mean, I don't know the mathematician who came up with it, but it works. Here's my recommendation too. If you're feeling overwhelmed, which I hope at this point all of you probably are, because this, unless you've taken this class before, you would never have seen this. The best way to practice completing the square is to actually practice it on trinomials that do factor, because your answers are going to be whole numbers. As you can see, the answers here aren't whole numbers, because at some point we're going to find the square root of a non-perfect square. So let me go through the whole thing and show you. You can if you want. If you can. I'm going to go through real slow. It's going to be up here for a while. Okay. So here's where I began. It's like I'm telling you a story. If you want to copy this example down, it's in the textbook, right? It's in the textbook if you wanted to refer to it. I literally took a screenshot because this one image shows everything. Okay. I have the x squared minus 14x plus 16 equals 0. I'm trying to solve the quadratic. It doesn't factor, so I'm stuck. So I decide I'm going to complete the square. What I'm going to do is I'm going to turn this into a perfect square trinomial, because here's what I do know. If I have a perfect square trinomial, I can solve it. And I'm going to show you how. But in order to complete the square, I first need to get rid of this C value, because when I work that formula, that b divided by 2 squared, I'm coming up with a new C value. So this one's got to go. So the first thing I'm going to do is subtract my 16, which turns my equation into this. X squared minus 14x equals negative 16. Now I'm going to complete my square. I'm going to use my little formula, which if you visualized your tile, your x squared, 7x's, 7x, you're going to break up your 14. What would you need in here to finish your square? It would be a positive 49. B divided by 2 squared. So now I know I can add that to my trinomial. But what's my issue? If I add something, no matter what it is, if I add something to the left side of an equation, what else do I have to do?
Add it to the right.
I have to add it to the right. Otherwise, the value of my equation is changed. So I add the 49 to both sides. So now my trinomial on the left, x squared minus 14x plus 49, that's a perfect square trinomial. I just created that. And I didn't change the value in any way. But the reason I wanted to do that, could I solve for x here? Could I just get x alone if I had x squared minus 14x plus 49? I think I could just isolate x. No. But if I rewrite this as the two factors that would have multiplied to give me that, which is x minus 7 times x minus 7, could I isolate x and just get it by itself here? Yeah, using inverse operations, I can get x alone there. What are the two things happening to x on the left side of that equation? We're subtracting 7 from it, and then we're squaring it. So how do you think I could just undo that?
Add 7 and find the square.
In what order?
Would you square root it first because you did that last?
Yep. So when I have it written at this level, the reason I do that is because I can solve for x here. So I'm going to find the square root of both sides. Because then it becomes x minus 7 equals positive or negative square root of 33. Now the square root of 33 is irrational. So from this point forward, you're going to see it's not an equal sign. Your eyes aren't playing tricks on you. It's like a little squiggly equal sign. Because That's estimated, that's rounded. If an irrational number, goes on forever, never repeats. So we're estimating it to be 5.74. Notice this is the point where it goes from a straight equal sign to a squiggly.
Yeah.
That's why. The square root of 33 is approximately 5.74. So we're just going to change that number out. So here's what I know from this point. When I find the square root, yes, positive 5.74 times positive 5.74 gives me 33, but also negative 5.74 times negative 5.74 would give me a positive 33. This is where I get two answers, because the square root of 25 is 5 and negative 5. Once I find the square root of both sides, my equation becomes x minus 7 equals positive and negative 5.74. So x minus 7 equals positive 5.74 and x.7 equals negative 5.74.
So if we're like, if we got tested on that, we would put that line under there.
If you put an equal sign, it'd be fine. Especially if on a test it might be a whole number. Like you're gonna practice one in a few minutes that is factorable because you're gonna know the answer going in, but you're gonna practice this method with it. Okay. If you wanted to use the little squiggly equal, good. You could just use an equal sign. I'm okay with that. So now that I have two equations, I can solve them because x is by itself. If I add 7 here, which would make this 12.74, and x would be by itself here if I add 7, which would make it 1.26. I know the decimals seem very crazy right now. When you do this, if you're going to have irrational numbers like that, especially on the park exam, you'd have a calculator, most likely. So just to recap where we started and how we got there. I noticed early on that I couldn't factor that. I just couldn't find factors of 16 that added up to negative 14. Okay? So I decided instead of trying to continue on and beat myself with trying to come up with factors, I'm going to create a perfect square trinomial. And I'm allowed to do that. I'm going to get rid of the 16 and I'm going to use this formula to make x squared minus 14x into a perfect square trinomial. The reason I want to do that, I can rewrite it and actually solve for x. Most important thing, if I add 49 here to complete the square, I would have to add it to this side as well. Whatever I do to one side of an equation, I should be able to. From this point and beyond, you're solving for x. Inverse operations, if it's being squared, you square root. If you're adding, you subtract. If you're multiplying, you divide. We're going to go through an example, and we're going to go through together. Okay, so that you can see this in action.
How are there two different answers?
Well, this is still a quadratic, so it crosses the x-axis 2 times.
Oh, yeah.
The reason there are 2 is from these two symbols right here. This x minus 7 will equal a positive 5.74 or a negative 5.74, so that's where you would get 2. I'm sorry?
But when you add 49,
Yep.
it's not the same as the original equation. So
Correct, but I can do anything to an equation as long as I do it to both sides. Did I change the value by adding 49 to both sides though?
But you didn't subtract that later on.
What do you mean subtract it?
Like, two.
If it's built into both sides, it's still reflected, meaning the value of x, because I'm still solving for x. The value of x wouldn't have changed if I did the same thing to both sides. If you only added 49 here and left that as a negative 16, your answer wouldn't be correct. We're going to go through an example with that I'm going to tell you the answer in the beginning. We're going to go through that. So I'm going to walk through this one to show you a little. If you want to try this one as we go, you can. I'm going to go through as well. I'm going to go through relatively slow. There are not factors of 15 that add up to 9. Okay, the nice thing is I'm kind of giving you that heads up. So I'm going to complete the square. I'm first going to subtract 15 from both sides, which makes my equation x squared plus 9x equals negative 15. Now I can use my formula, b divided by 2 squared, to complete the square. B is 9. 9 divided by 2 is 4.5. 4.5 squared is 20.25. You don't have to worry about that. So I know that what am I going to add to both sides of this equation? I'm going to add the 20.25. So my equation will look like this. Now the reason that I actually want to do this is because I can rewrite that trinomial as the binomial squared. But now I need to figure out what is the second term of that binomial. What is the number that if I multiplied it by itself gave me 20.25, but if I added it with itself would give me 9.
Where did the 5.25 come from?
I added sorry, I dropped it. The number in here, and this is, I don't want to say shortcut, but I'll use the term. A shortcut for when you break out the factor, the number that would go in here is that b divided by 2. It's always going to be that number that goes in. The reason I would still recommend writing it out at this level, if you don't show that you're adding the 20.25, you might forget to add it to the other side. And that's just something I picked up over time. When students are like, oh, once I know this, I can just factor and be done. The students that try to skip ahead there forget and end up leaving this as a negative 15. And thank you for pointing out that I didn't show that I added the 20.25, because that would have been, if you didn't know that that had to be added to both sides, you're mistaken. Go. Which question?
Where did you get the 5.25?
Here, when I found, hold on one second, let me do it this way. Take a look now. When I found that C value, I had to add it to both sides, making the left side of my equation x squared plus 9x plus 20.25, that perfect square trinomial. But the right side of the equation, I can simplify that. Negative 15 plus the 20.25 would have given me a 5.25. So the reason I like to show this example, because a lot of students when they see it, they're like, oh my god, it's decimal. It doesn't matter. When you find this b divided by 2 value, this is the factor. You're actually finding the number that when I multiply it by itself gives me the c value, but when I add it with itself, or double it, it gives me the b value. So by doing this, you're actually finding the factor. It might save you a little bit of time. From here I can solve, but we're going to go through an example. You're going to try an example that is already factorable. You're not going to factor it. I'm going to tell you the answers in the beginning so when you go through the process, you know what answers you're looking for. Do you want me to finish it? I'll finish it. I want to finish it. So if I have x plus 4.5 squared equals 5.25, at this point, I only have x in one spot. I can solve it. I can do whatever was done in reverse and get it along. So I'm going to find the square root of this side, square root of that side, which gives me x plus 4.5 equals positive or negative. I'll leave it as the square root of 5.25. Actually, you know what? I'll do it right now.
So would we have to go all the way? What do you mean? Like if you didn't do it.
Pardon the interruption. Can I please have Sarai Flores to the main office with her things for pickup?
Sure. You got it.
If we were were like on, if you gave us like a quiz or something, but without a calculator, could we just leave it as a squared 5.25 or?
It would be a easy enough number to like come up with it to the nearest 10, especially for practicing purposes. Okay, so here, I used the calculator for that square root. X plus 4.5 equals positive or negative 2.29. So to finalize this, that means X plus 4.5 equals 2.29 or X plus 4.5 equals negative 2.29. I can subtract 4.5 from both sides. So X would equal negative 6.79 and X would equal negative 2.21. Did I do that?
Right, I'm not.
Yes, I did. Yep. So these would be our answers. I'm going to post a YouTube video with a little tutorial and 3 practice problems, all 3 of which are factorable. It's so much easier to practice this with numbers with quadratics that are factorable. We're going to do one right now.
I did the negative 2.21.
I did 2.29 minus 4.5. Oh, that's negative 2. And then here it's negative 2.29 minus 4.5, so it's negative 6.59. Because by square rooting it's positive or negative, so when I write it out here, this would be the positive and this equation would be the negative. Because you'll have 2 answers. Ready to try one?
Yeah.
We're going to try one that's factorable. I'm going to tell you the answers in the beginning, because it doesn't matter. All right, x squared plus 4x minus 21 equals 0. The answers are negative 7 and positive 3. If I factor that out, factors of negative 21 that add up to 4 would be a positive 7 and a negative 3. X plus 7 equals 0. So my answer would be this. Right? This is not the important part. I want you to do this by completing the square. So to complete the square, you will get the same answers if you do the process right, and that's why I like to do examples like this so you know what you're looking for. I'm going to pause the video here.